Okay, we're going to review how to graph lines and find equations of lines. So lines can be graphed on the Cartesian coordinate system, and that's broken up into 4 spaces. We're going to start off by plotting some points. And basically, this is the x-axis, and this is the y-axis. And x has the direction of, this direction is positive, and left is negative. Of course, here is my 0, 0, my origin. And my y value, we go up is positive and down is negative from the origin. And our point looks like xy. So in quadrant 1, if we're going to the right and we're going up, we've got both our positive coordinates, the x and the y. In quadrant 2, we have to go left, which is negative, and then up, which is positive. So that's my x, that's my y. And quadrant 3, they're both negative, left and down. In quadrant 4, we go to the right and then down. So those are the signs of each of the coordinates in the quadrants. So we're going to, real quick, just plot -3, 2, and 5, 0. -3, 2 is in, it's left and up, so it's quadrant 2. So we can tick off and go backwards, 1, 2, 3, up 2, and there's -3, 2. And 5, 0, that's a 5. 5, 0 is 5 to the right, 1, 2, 3, 4, 5, and then 0 up and down, which actually lands us on the x-axis. So that's actually called, this is 5, 0. That would be a x-intercept. Okay. Now, starting off, here's a question. So is that a point that's a solution to that ordered pair? Is that ordered pair a solution to that equation? So to check, we're going to take our point, -1, 4, and we know this is xy, so we can call x is equal to -1 and y is equal to 4, and we plug it into that equation and see if it yields a true statement. So 4 minus 1 plus 3, 4, does that equal to 8? It's 4 plus 12. So yeah, that's true, which means, therefore, that means that -1, 4 is a point that lies on the line. On the line, 4x plus 3y equals 8. So we have one point if we wanted to graph it. Now we have one. Now we're not going to be guessing in all these points to graph it. So what we're going to have to do is we're going to have to find more points to graph. And by the way, how do we know that this is an equation of a line? When you look at the x and the y, there's no exponents to it. No exponent means there's a power of 1 to each of them, which means its degree 1 is linear. Okay, if both of them are degree 1, it's a line. And we know what lines look like. It will have positive slope, negative slope, or it can have a 0 slope or no slope. So, to find more points on this particular line, we can plot some points, or actually we could guess x is equal to 0, for example, and find the corresponding y coordinate. So this is what it's looking like. X is 0, and what would y be? So we would plug in 4 times 0 plus 3y equals 8 to find the y value, and you can, create a table to find a whole bunch of points. So here we guessed x is 0, and this becomes 0 plus 3y equals 8, y equals 8/3, or 2 2/3. So we know where to graph it. We can guess y is 0 if we wanted to. Y is 0 would be 4x plus 3 times 0 equals 8. And then we get 4x equals 8. X is equal to 2. So there's another ordered pair. And again, don't forget, we also have the -1, 4 that we plugged in and checked and found that was a point. So we have 3 points. I think we can graph this now. The two with the integers are going to be easier to graph. So -1, 1, 2, 3, 4, right there. 2, 0. And let's see, if we graph it and connect it, we have our line. We really only need 2 points to form a line. And this one should fall on it, so we can use that to check 0. Oh yeah, somewhere in the neighborhood of between 2 and 3. 0, 2 and 2/3. And what we did here also, we noticed this is the point that crosses our x. That's our x-intercept. And this one here, when we plugged in 0 for x, that's my y-intercept. So that's kind of how we can find our x and y-intercepts. If you plug in x equals 0 for x, you find your y-intercept because it's always going to have x as 0 left and right. And similarly, for the y equals 0, you can find your x-intercept. Given 2 points, x1, y1, and x2, y2, points on a line. Your slope of that line is y2 minus y1 all over x2 minus x1. Points. It's pretty much measuring rise over run. That's your distance of your y, and this is your distance. And of course, if they're both positive, plus plus, you have a positive slope. And if we're going this way, we can rise and then run left. That's plus, run left. That's a negative slope. So what we also can do is we can take one of those points and hold it variable. And we can find an equation of a line. That's this x, y stands for all the points on the line, and x naught, y naught is just a particular point on the line. You have m equals y minus y naught all over x minus x naught. And then we can clear our fraction. X minus x naught equals y minus y naught. And this is what's called the point slope equation of a line. I like to put this on the left side. So it's y minus y naught equals m x minus x naught. So and we can find equations of line using that formula. Okay, and a lot of times we do like to put the equations of the lines in the slope-intercept form of a line. I'm sure you've seen it before. It's y equals mx plus b, where m is our slope and b is our y-intercept. So 2 forms. You can actually find an equation using both, but a lot of people prefer this one, but then you do have to change it to that form. But whichever one you're more comfortable with. I used to find it using this, but I find when I teach calculus, it's easier to jump to the point slope equation of a line. Let's find some equations. We're going to find, how about if we just find the slope and the y-intercept and graph. Two x plus 3y equals 9. Okay? So in order to find, since we do want the slope and the y-intercept, it's probably easier to get it into the slope-intercept form. So we solve for y. by subtracting 2x on both sides. And then we got to divide by the 3. We want to divide the whole side by 3, which means then it's distributed to both terms. Minus 2/3 x plus 3. And so my slope is minus 2/3. And my y-intercept, it's 3, but basically you plug in, you can see why it's the y-intercept. You could plug in 0 here, and that zeroes out, and then we get y equals 3. So 0, 3 is my y-intercept. It's an ordered pair. So to graph, we can actually start. This is a different way of graphing. We can find another point, but we can use our slope also to graph. But you have to start on a point on the line. You got to start at your y-intercept, which is 1, 2, 3. So there's my y-intercept. My slope is -2. So since my m is minus 2 over 3, remember it's y over x, rise over run. Rise over run, which is your rising 2, -2 actually. 1, 2, running 3. 1, 2, 3, which gets me to the point 3 to the right, 1 up. And then we can connect those points and extend them. And there's my equation. This is the graph of my equation of my line. And as you can see, it's a negative slope. That's down to over 3. And that's my y-intercept. Going on. If we have parallel lines, it means they have the same slope. So that would mean m1 is equal to m2. If I have perpendicular, then they are the negative reciprocal of each other. I'll write that, negative reciprocal. And what that means is basically if I have m1, then m2, my second slope would be the negative, the opposite, because, you know, one's positive, one's negative, but it's also the reciprocal. And the way we write a reciprocal is like that. So given one slope, the other slope is you take the opposite and the reciprocal. So let's find some equations of the lines. So we want to find the equation of a line that has slope 2. So slope 2 means m is equal to 2. And y-intercept is -5. So we do have this point. We can use either equation, but since we do have, basically that is my b, right? Because that is my y-intercept, is your b. So using this one is probably a lot faster than the other one. Using y equals mx plus b. Because all we have to do, we have our m and we have our b, and you plug it in, and there we go. That's it. It's my equation with slope 2 and my y-intercept b. What if, let's make it a little harder. Okay, find the equation of the line that contains these 2 points. So I think in this case, we might want to try y minus y naught equals mx minus x naught. Now all we need here is a point. Well, we've got 2, so it doesn't matter which one we use. You can use either one, you'll get the same answer. And the slope. So it seems like we need to know the slope. So let's find the slope. The slope is, remember, it's rise over run, which is the y values. 4. So rise over run, it's going to be the y values, or the rise. So we'll start with the 4 minus 2, and then we subtract the x values, minus 1, minus 3. If you start with this y value, you have to start underneath it with that x value, which is 2 all over minus 4, which we can reduce to minus 1/2. So there's our slope. And now all we need to do is use one of these points. We can use either one. I'm going to use the first one. And for the first one, I'll use x naught equals 3, y naught equals 2, and plug it into our equation here. So y minus 2 equals, slope is negative 1/2, x minus x naught, which is 3. Y, I'll add 2 to both sides, equals minus 1/2 x, distribute, it's plus 3/2 plus 2. We need to find a common denominator. So 2 over 2. So y equals minus 1/2 x 4. It's 4 plus 3 is 7/2. And that is our equation of our line that goes through both of these points. Okay, we're going to find the equation of a line that's actually perpendicular to this equation of the line 3x minus 2y equals 6 and passes through the point 1,5. So we are going to use y minus y naught equals m x minus x naught, but we usually want to find m first. So we want to find m. And what do we know about m? M is perpendicular to that equation of that line. So remember, m is going to be the negative reciprocal of this m, of that line. So let's find the perpendicular. It's called m. We'll put a little perpendicular sign there using 3x minus 2y is equal to 6. So we got to basically put it in the y equals mx plus form. Solve for y. Okay. So I'm going to subtract 3x on both sides. 3x minus 3x. I get minus 2y is equal to minus 3x plus 6. Divide by minus 2 to every term. And I get y equals 3/2 x minus 3. So this is not the equation of the line we want. This is the equation of the line that's perpendicular to the equation that we want. Okay, so that means this is my m perpendicular. This is my perpendicular slope. So I want a slope that's perpendicular to that. So the m I want, I call that m, is the negative, the opposite, and the reciprocal. And I'm going to box this so that I know that's the one I'm going to use. That's the one I'm going to plug in there. So now all we have left to do is find a point. Oh, we have a point. So there's my x naught, y naught. X naught is equal to 1, y naught is equal to 5 from that point. So y minus 5 is equal to minus 2/3 is my m, x minus 1. Just get it into our slope-intercept form and we'll be done. So add 5 to both sides, plus 5 at the end there. Y equals, distribute, minus 2/3 x plus 2/3 plus 5. And get a common denominator. Y equals minus 2/3 x plus, it looks like it's 17/3 is my final answer. That's the equation of the line that has perpendicular to this line and passes through 1,5. Thank you.